to Lecture 9, Global Warming, Emissions, and Energy. So, we're going to start this lecture off by looking at observations of global warming. The Earth has warmed significantly since the Industrial Revolution. The most recent years have been the warmest since we've had continuous global measurements from thermometers around the globe. We'll talk about that. In fact, if you go back to 1880, since we've had continuous, reliable observations throughout the globe of temperature from thermometers, last year was the hottest. 2014 was the second hottest. And you might remember from our discussion of weather and climate that climate's over a scale of decades, centuries, millennia. So you might be thinking, 1 or 2 years, right? That's not enough to say if the world's warming up, right? True, but if you look at the observations, you see that over the past several decades, the Earth has warmed. And 9 of the 10 warmest years, in fact, have occurred since about 2002. So then, we'll be looking at increasing atmospheric carbon dioxide levels. Carbon dioxide is an anthropogenic greenhouse gas. It traps the planet's heat, traps infrared radiation. And CO2, that's carbon dioxide concentrations in the atmosphere, are higher than they've been going back 800,000 years before the early 1900s. We'll talk about that. And we'll talk about why CO2 concentrations are at unprecedented levels. What are some of the sources of them, along with other greenhouse gases like methane, nitrous oxide. Okay, where do the greenhouse gases come from? And then we'll start talking about energy. There's a relationship between energy usage and greenhouse gas emissions. Okay, when you use energy to turn the lights on at home, drive your car, fly, there's CO2 and other greenhouse gases released. And of course that, as you should know from an earlier lecture when we talked about the greenhouse effect, the greenhouse gases contribute to trapping the heat of Earth. So, global direct measurements of temperature have only been available since the late 1800s. That's how long we've had continuous, reliable measurements of temperature from thermometers around the globe. Now, we can still determine temperatures prior, and that requires the use of proxy measurements. The thermometer was invented in the early 1700s, but it took some time for it to thermometers to be distributed around the entire world. Okay, when we talk about global temperature, obviously we need global measurements. So, how do we reconstruct temperatures before what's called the instrumental record, or modern meteorological record? We can use proxy measurements, such as ice core isotope data, the ratio of different isotopes in ice cores tell about temperature, okay? And isotopes are heavier atoms, okay? So there's the more common atoms with a certain number of protons, that determines what element the atom is, a certain number of neutrons, a certain number of electrons, but the isotopes have more neutrons, okay? And they're heavier. And ice cores can be obtained from the Antarctic ice sheet, along with Greenland ice sheet. Okay. There's coral reef isotope data. The isotopes in the coral reefs, there's very large ecosystems at the bottoms of oceans, can tell one about temperature. Also, tree ring width can be used to determine temperature. Every year a new ring forms on a tree, and some of those trees are very old. For example, the redwoods in far northern California are hundreds to even a few thousand years old. Okay, But ice core isotope data and coral reef isotope data can go back even further than a few thousand years from tree ring width. Isotope data from the ice cores and coral reefs can go back hundreds of thousands of years. Now, let's turn our attention to the recent warming. And you'll see it's been a very significant warming in recent times. This figure is one of the more cited figures in the global warming community. Okay, it really was a landmark figure when it was released. It was released in a publication by Michael Mann of Penn State and his colleagues in 1998. And what it does is it looks at northern hemisphere average temperatures for the millennium, the 1,000-year period from 1,000, the Middle Ages, to 2,000. Basically 2,000, about 1998 or 1999, okay, when the paper came out. And as you can see by this legend, the data from thermometers is shown in red, whereas data from tree rings, corals, ice cores, what we were talking about, right? The proxy measurements, also called the indirect measurements. Thermometer measurements of temperature are sometimes called direct, and proxy measurements are called indirect. Just another name, okay? As you can see, only since the late 1800s have we had the measurements of temperature from thermometer, okay? By the way, these temperatures aren't for the entire globe. They're for the northern hemisphere. But that's where most of the world's land is. And that's what Michael Mann was looking at. And by the way, we're not looking at exactly at temperatures here. We're looking really at temperature anomalies. Okay. The anomaly is basically the departure from the average. In this case, we're looking at departures in degrees Celsius from the 1961 through 1990 average, 30-year average northern hemisphere temperature. So, if that year has an anomaly below 0.0 degrees Celsius, a negative temperature anomaly, it was cooler than the 1961 through 1990 average. If it was above, that year's temperature anomaly is positive, above the 0.0 degrees horizontal line, then that year was warmer than the 1961 through 1990 average, and the values tell you how much warmer, okay? So the higher up you are, right, the warmer that year was, right? And the gray represents uncertainty. Notice there's more uncertainty as you go farther back in time. But thermometer measurements are much more accurate, and they're also more precise than the proxy measurements, which is why the uncertainty has gone down. Okay, we're more sure about the accuracy of the northern hemisphere temperature measurements in the last 150 years or so. And the black line is basically a moving average. It smooths out the year-to-year variations because temperature can greatly increase or decrease by an individual year. But the black moving average gives you a more better look at the trend, okay, what's happening. So you see temperature goes up and down, okay? If anything, from the year 1000 to the late 1800s, the net trend in northern hemisphere average temperature was a slight decrease. You see it's pretty flat if you're going to plot a Microsoft Excel line, okay, from 1000 to 1850 or so. It'd be pretty flat, but if anything, it's a slight decrease. But then you notice a dramatic spike in northern hemisphere temperature in the past 150 years. This figure is sometimes called the hockey stick figure, or hockey stick diagram, because that's what it resembles, okay? Here's the end of the hockey stick. So it's very apparent how in the recent times, 150 years, northern hemisphere temperatures have dramatically increased, okay, compared to what the trend was going back hundreds of years, okay, right? They're much higher now than they were, okay, going back hundreds of years. And now, this figure is for northern hemisphere temperatures. If we were going to examine the global average temperatures and see how they've changed over the past several decades, you'd see the hottest years of recent years, like I was saying at the beginning of the lecture. So basically, the global average surface temperature in 2015, last year, was the warmest since 1880. Okay, 1880 is when continuous global temperature measurements from thermometers, direct measurements of global temperature began. Okay, we had measurements of temperature from thermometers going back before that, but we didn't have enough global coverage, right? If, there's more measurements in, say, certain regions of the world, like North America and Europe, and not enough in other regions of the world, could be Africa, South America, then you're not really going to get a global temperature, right? And this the fact that 2015 was the hottest year for the world, going back to 1880, stands out. But again, you can't just look at 1 year. You can't cherry pick it, right? Maybe you're thinking, oh, this was just 1 year, an anomaly. Not so. 9 of the 10 warmest years in the modern meteorological record, since 1880, have occurred in the last 14 years. Okay, the 5 warmest were 2015, 2014, 2010, 2005, and 2007. Okay, I started teaching at San Jose State in 2012, and so I've had to update the slides, okay, to account for the 2 new warmest years. Okay, when I started teaching, actually, 2010 was the warmest year on record for the globe. And by the way, you might have heard this in the news, 2016 is going to replace 2015 as the hottest year. Okay, so that's now the last 3 years. Okay, 3 consecutive years of becoming the hottest on record. Okay, so after this year, it's going to be 2016 was the hottest, 2015 was the second hottest, 2014 was the third hottest. By the way, the only year, the one of the 10 warmest years that didn't occur in the past 14 years was in 1998. Okay, and if you're interested, you can look at an article talking about 2015 being the warmest year this data is from NASA. Okay, you can also look at the data here. Okay, so now let's look at how the global temperature's changed since 1880. Let's look at a figure. Okay, well, first we'll look at global temperature anomalies from 1880 to 2014. These again are anomalies. They're showing how the average yearly global temperature has changed, and the anomalies are showing relative to the average from 1951 to 1980. Positive anomalies mean warmer years, negative anomalies mean cooler years than that 1951 to 1980 average. The black boxes are the yearly average global temperatures. The red curve basically smooths out the data. Looks at what's called a 5-year running mean. Takes the average of the 2 previous years, that year itself, and the next 2 years. Okay? To give you more of a look at the net trend. And the net trend is pretty apparent, right, for this figure. Okay? You notice that global temperature decreased slightly over time from the late 1800s to the early 1900s, around World War I. And then around World War I is when the temperatures started going up. Now, yes, they didn't go up every single year. Okay? Could go up for a few years, go down, go up, but you got to look at the net trend, and the net trend, as you see in red, or you can also see it if you look at the annual mean temperatures and try to see what they're doing over time. The net trend was the increase from World War I to World War II. Okay, then global temperatures leveled off for a few decades, from about the time of World War II into the mid-70s. Okay, there wasn't a whole lot of change. This was actually due to what's called global dimming. Even though greenhouse gas concentrations were going up, aerosol amounts were going up too. Okay, so on the one hand, more greenhouse gases were causing more of Earth's outgoing infrared radiation trapped, absorbed, and before it leaves the atmosphere and emitted back down to the surface. But there were also a lot more pollution particles in the air. Dust, salt, smoke, and aerosols tend to be reflective and they have a cooling effect. Okay, so that was counteracting the increase in greenhouse gases. Okay, the increase in aerosols was masking it. But then after the mid-70s, the increase in greenhouse gases was outweighing the increase in aerosols, and that's why temperatures started going up again. And in fact, more recently, global temperatures have gone up faster. Okay, so for 1880 to 2014, this is the figure for that. And then what you really notice is how 2015 was off the chart, right? It was off this chart, which is why a new chart had to be made, okay, with the greater vertical extent, right? Higher maximum Y value, right? And then 2016 is going to be even higher. By the way, Mount Pinatubo erupted in 1991. It caused a global temperature decrease of about 0.2 Celsius the following year. You can actually see that. This is 1991 global temperature, and then 92, okay? But then it started going up again, the temperature did, okay? 2015 was 1.57 degrees Fahrenheit warmer than that 1951 through 1980 average, okay? From 1915 to 2015, average annual global temperature increased by 0.97 degrees Celsius, 1.75 degrees Fahrenheit. Okay, so here you go. If you're wondering how much did global temperature increase by, well, in the last 100 years, right, it increased by almost 2 degrees Fahrenheit. And most of that warming has actually occurred just in the past 4 decades. Okay, a majority of that warming, about 2/3 of that warming, has occurred just in the past 40 years, which shows us that actually temperature is warming up faster more recently. And one can see this if you compare the slope of the temperature increase in the earlier part of the 20th century to more recently in the later part of the 20th century and in the early 21st century. Okay.